My name is Alice Law. I would like to welcome you to our webinar today titled 5G IoT Edge Design Consideration. What is 5G? 5G is next generation cellular network. 5G standard divide frequency into two groups, FR1 and FR2. Most early deployment will be in the FR1 space. Research is ongoing into using FR2 frequency, which are also known as millimeter wave frequency. 5G standardization is still progressing. New works are still under development, such as antenna, advanced sleep modes, etc. Early release 15 focused on non-standard new radio, which is adding 5G base station to LTE base station while LTE is operating only in FR1. Regular release 15 focus on standalone new radio, which 5G base station without LTE involvement. 5G release 15 initial delivery for non-standalone access in late 2017. Then in 2018, expand to cover standalone 5G that enable vendors for chip design and initial network implementation during 2019 this year. The final 5G phase 1 is scheduled to be released this year. 5G release 16 phase 2 is scheduled to be released next year. This phase will be based on an evolution of Internet of Things like sensor, device, vehicles, and bandwidth network layout. Main benefits of 5G. 5G is projected to bring three main benefits. Enhanced mobile broadband, faster speed for streaming 4K video, video conferencing, and virtual reality. Massive machine-type communication. Shorter delays mean reduced latency for connected devices that need quick reaction time, like connected car, robotic surgery, road safety, and industrial automation, and devices for safety-critical and mission-critical applications. Reliability and safety in the transmission is important. Ultra-reliable and low-latency communications. Increased connectivity, that means more people, more devices, should be able to communicate at the same time. Hundreds of thousands of Internet of Things optics could connect using cellular network for sensing, metering, monitoring use cases. 5G key service. Enhanced mobile broadband for high data rate communication. Good for video streaming, 3D images, work and pay in the cloud, augmented reality. Ultra-reliable and low-latency communications for low-latency and reliable applications, such as industrial automation, defect inspection, pattern and facial recognition, self-driving cars. Massive machine-type communication, also called MIoT, for hundreds of thousands of connected devices, such as smart buildings for light switches, appliance, security system, also for smart city for traffic management, parking system, street lights, waste management system, fire and gas chemical detection. Element of 5G technology. The front runners include millimeter wave, small cells, massive MIMO, full duplex, and beamforming. Millimeter wave. They call millimeter waves because they vary in length from 1 to 10 millimeters, compared to the radio wave that serve today's smartphone, which measure tens of centimeters in length. Small cells. Carrier could install thousands of these stations in a city to form a dense network, that act like a relay team. Antenna on small cell can be much smaller than traditional antennas. This size difference makes it even easier to stick cells on light poles and atop buildings. Massive MIMO. Today's 4G base stations have a dozen ports for antennas that handle all cellular traffic, but 5G base station can support about 100 ports. A base station could send and receive signal from many more users at once, increasing the capacity of mobile network by a factor of 22 or greater. 5G base station will also have many more antennas than the base station of today's cellular networks. Installing so many antennas to handle cellular traffic also cause more interference if those signals cross. That is why 5G stations must incorporate beamforming. Beamforming. Focus a signal in a concentrate beam that points only in the direction of user. This approach can strengthen the signal chance arriving intact and reduce interference for everyone else. Full duplex. Today's base station and cell phone rely on transceiver and must take turns in transmitting and receiving information over the same frequency or operate on different frequencies. Full duplex allows a user to transmit and receive information at the same time. One drawback to full duplex is that it also creates more signal interference. This special echo cancellation technology. Challenge on 5G indoor network. 5G millimeter wave spectrum can't travel through door, glass, and around corners. This means any indoor 5G network in millimeter wave spectrum will probably need lots of antennas pretty much everywhere and to cover every corner of every room. Indoor cellular networks often use distributed antenna systems. Who pay for the in-building cellular networks? There are a variety of payment models for in-building cellular networks in terms of who pay and how much, who is responsible for maintenance. We don't expect 5G full coverage for a short period of time. Consideration before 5G indoor network ready. 5G supports 10 gigabit per second of throughput, which is 1,000 times more than we have today. A 90-minute movie takes 3 or 4 minutes to download on 4G network. With 5G, the same movie will take 10 seconds to download. 4G will be around for a while, but 4G may not even go inside. Alternate solution, Wi-Fi and cellular gateway. Use Wi-Fi 6 for indoor and 5G for outdoor communication. Wi-Fi 6 is backward compatible but not 5G. We might want to add 4G in the gateway too to get full coverage. 5G uses regular spectrum, which is expensive, whereas Wi-Fi uses unregulated spectrum, which is free but will be crowded. What is the edge of IoT? There are many answers, depending on who do you ask, where do you ask, and when do you ask. The edge of IoT is where the action is. Edge, bring processing closer to the data source, and it does not need to be sent to a remote cloud or other centralized system for processing. Edge means different thing for different industry. For automotive, in handheld device used by the service technicians, smart sensor for smart car, point of sale system for retail, RFID for supply chain. Where is the edge? There is the network edge, cloud edge, and edge device. Again, depend on who you talk to. When you talk to cloud provider, They will tell you something like smaller data center that is a bit closer to the end user. For industrial edge, it's the border between the operation technology and information technology worlds. Network edge provide a fair trade-off when it comes to privacy, latency, energy consumption, processing power, cost of data communication, and is also well suited for AI application. In my opinion, edge intelligence needs to be more on the service themselves where data is generated. Edge is everything beyond the data center and cloud. For now on, whenever I say edge, it refers to edge device where the thing is. 5G networks are only part of the solution. The other necessary element is device or edge that customer can be used to access the network. Benefits to embed intelligence at the edge. This approach offers several benefits. Data protection. As the edge device within the premise of the business, it can keep safe from intrusions. Edge computing cuts back on total volume of traffic, thereby shrinking the attack vector. Edge computing is sometimes used as a means of distributing data across many devices. Faster response time. Analysis the data at the edge will cut down the data transmission time to the cloud and processing time. Core effectiveness and scalability. Reduce number of components to cut production time and cost, significantly cut down the transmission time to the cloud. For AI and machine learning, we will use cloud for training and learning purposes. Use edge as inference model only. It won't be taking over the cloud computing by any means. The edge and clouds will work together to deliver the true value of data analytics to the user. Some IoT users, such as factory and smart city, may also insist on the data being stored and managed locally. Real-life use case for edge. Edge use case are more of like 5G use case. They are different between edge for IoT and non-IoT. For non-IoT usage refer to the data pushed from the cloud to user, such as gaming, video streaming, and AR, VR applications for customer experience in retail. For IoT only edge, that is data from IoT device to pull to the cloud, such as industrial, smart city, connected car, medical, and healthcare, automation, AI, and machine learning. Fundamental aspect of intelligent edge device. Intelligence starts at the edge. For IoT only start with the edge node, which is the sensing and measurement entry point of interest. This is where the physical world interact with computational data analytics. Connected machines can sense a wide array of information that will be used to make key decisions. The interpretation stage is where edge analytics and processing transform the measured data into an actionable event locally. Only the valuable information should be sent to the cloud for predictive or historical processing. Power management and security should consider in the early edge design stage. I will discuss these two areas separately later in this webinar. Edge device design flow example. This is a simplified design flow example. Sensor collect data from the edge of device or thing. If the data doesn't need to be filtered, it just needs to send data to the cloud or other device. Then the other device or cloud is sent back to the command for action, like turn on and off the light through mobile phone. If the data needs to be filtered and processed, we can use the traditional algorithm to process the data, such as if the data is out of range, then the alarm will be on, for example, like smoke alarm. We can also use AI or machine learning to process data and respond with the real-time decision. For example, like defect inspection in factory or car sensor in self-driving car. Major design component for edge. There are several major design components for edge, like sensors, wireless communication chipset, CPU, GPU, FPGA, memory, analog parts, and antenna. Sensors, temperature sensor, sound, vibration, pressure, motion, image, gas, position, moisture, rotation sensor, audio and video, and many more sensors. Wireless communication chipset. The protocol can be Wi-Fi, cellular, 4G or 5G, or both, Bluetooth, Zigbee, and many other wireless communication protocols. CPU, essential processor, is handle basic instruction and allocate the more complex text to other specific chipset to get them to do what they do best. GPU is graphic processor unit which work well with deep neural network computation because it allows parallel computing through thousands of threads computing at a time. FPGA, field programmable gate array, mean they can be configured by the user after manufacturing. FPGA contain programmable logic block that can be wired in different configurations. FPGA was GPU for AI and machine learning at the edge. GPU requires CPU, but FPGA have processor in fabric. GPU connect data source through a standardized bus, but FPGA can connect data source directly to the pin of the chips. The architecture of GPU is single instruction multi-thread, but FPGA has flexible architecture, allows massive parallel computation. GPU use software programming and FPGA use hardware configuration. Engineering development cost for GPU is lower than FPGA because FPGA take longer time to compile, synthesis, and place and route. But production cost of GPU with CPU will be higher than FPGA alone. Smaller board size and less assembly and test time, which will increase the production yield. 5G IoT edge architecture with FPGA. FPGA can connect to one or more sensors through the same or different interface directly to get data. It's also connected to the RF module or component. We will send and receive signal from the cloud. Once FPGA get information from the cloud and the data from the sensor, it will process the information and make real-time decisions and send real-time command to the machine for actions. Let's look at the right-hand side FPGA internal block diagram example to see how FPGA process the information and data. First, FPGA start receiving sensor data through sensor interface. Sensor algorithm will be used to process and extract information from the sensor data, then send the useful information to the intelligent machine, which include multi-core GPU and AI and machine learning blocks. The intelligent machine is the brain of the FPGA. It can be simple logics or can be complex inference model. At the device edge, there will be no learning or training performed. All learning and training should be done in the cloud or network edge. The intelligent machine will receive information from the cloud. Those information with the sensor data can help the intelligent machine to make real-time decisions and send command to the external machine for action. The FPGA will also send information back to the cloud through 5G network for further learning. RF signal processing can be implemented in the digital domain. FPGA have periods very flexible solution. FPGA have provided very flexible solution for implementing the digital front end and interfacing requirement for recent radio generation. The same level of flexibility and programmable must be pushed closer to the antenna in the new generation of radios to move forward the growth of software-defined radio. Direct RF sampling integrated with highly optimized RF digital signal processing engine offer a much more flexible approach to traditional analog frequency translation and filtering. All these functions can be performed by a single FPGA, which will save power, space, and weight, reduce latency and production costs. With processor trusting will add extra layer of security for the system. FPGA also includes software decision forward error correction to improve data quality for high-speed communication systems such as 5G. Power management. Power consumption is one of the design considerations for IoT Edge. The budget should add up all the components' power consumption, which should be less than the source of power. To choose the power source, especially your energy harvesting system, will be based on the Edge power budget. Security feature of the Edge. The Internet of Things comprises of widely diverse range of device types, from small to large, from simple to complex, from consumer gadget to sophisticated systems found in DoD, utility and industrial and manufacturing systems. Standard PC security solution won't solve the challenge of IoT Edge. There is no one-size-fits-all security solution for IoT Edge. Security requirements must take into consideration the cost of security failure, the risk of attack, available attack vector, and the cost of implementing a security solution. Other considerations in design IoT Edge. The most important thing to consider is the application usage and the trade-off between power, size, and cost. For your attention, in summary, to design IoT Edge, build multiple wireless communication protocols to cover both indoor and outdoor communication. Use FPGA for AI machine learning process. The benefit include add extra layer of security and improve data quality for high-speed communication system. Question and answer. The first question is, will US get behind from China? My answer is, I don't think so. AT&T announced that they will deploy 5G next year. As I said before, 5G networks are only part of the equation. The other necessary element is device or edge that customers can use to access the network. Now we need to start work on the edge to catch up China. The second question is this hard for a programmer to design in FPGA? Not really, but the engineer need to understand the electronic circuits and use familiar with the CAD tool. The last question is, someone asked for the chip manufacturer name. The wireless communication chipset manufacturer include Qualcomm, Intel, Broadcom, Nordic Semiconductor, and ON Semiconductor, and some other company too. CPU manufacturer include ARM, Intel, AMD, TI, Microchip, NXP. GPU have NVIDIA, AMD, and Intel. FPGA include Intel, Xilinx, Microsemi, QuickLogic. Memory have Micron, Microchip, Cypress, and many more. If you have any more questions, please feel free to email me. Thank you for your attending.